20 in this circuit. The condition is given, switch is closed at t equal to 0. Find V2 of t. So in this case, find the voltage. So you can easily find the current. The sum is very simple. So when I talk about inductors always deal with current. So when you talk about capacitor, the capacitor deal with voltages. So we'll have one more sum for the next type where I need to find only voltage across the capacitor. So over there the method will be a slight change. So in this case there will be no such changes as such. The 99% sum will remain as it is. If I need to find V2, just assume that you have to find I2 of t. Once you get I2 of t, my dear friends, you will get V2 straight away. Okay, so let's start with it. The first case, at t equal to 0 minus. At t equal to 0 minus, the circuit will remain open as it is. So about the current I1 of 0 minus, I2 of 0 minus will be 0. Second case. When I talk about second case, the second case condition is given as t equal to 0 plus condition. When I say t equal to 0 plus condition, my dear friends, that means my circuit will remain closed. So it will be plus minus 10 volt, 30 ohms. Again you get 10 ohms. So in this inductor, in previous case there was no current flowing through it. So initially the inductor will oppose the current. If it opposes the current, your circuit will become open circuit. So in this case, you have your I1, you have your I2. So for I1, at the resistance you get 40, I1 of 0 plus equal to, your current enters into negative, so it is positive. And for I2, since the circuit is open, so it is nothing but equal to 0 amperes. So your I1 0 plus will be equal to 1 upon 4, that will be nothing but 0.25 amperes. That's the value for I1 and I2. Let's go for t greater than 0 plus to find out the value for I1 of it and I2 of it. But since in this case I need to find only V2. For finding V2, my dear friends, I just only need to find I2 of t. So let's apply the KVL in the above equation. For finding t greater than 0 plus, nothing should be short and nothing should be open in terms of inductor and capacitor. The circuit should remain as it is. So it will be 10 volts shorted, 30 volts, it will be 10 ohms, having an inductor 0.2 Henry. So this is your I1 of t and this is your I2 of t. So let's apply KVL in the above equation. If I apply KVL in the equation number 1, or if I say equation loop 1, KVL and loop 1, we get, so at the resistance you get 40, I1 of 0 plus. So in 30 you have one more current flowing and is in same direction, so you have plus 30, I2 0 plus equal to, your current enters into negative, so it will be positive. That's the equation number 1. So apply KVL in loop 2. So this is your loop 2. So in this, in 30 ohms you are having it 30, I2 of 0 plus. But in 30 you have one more current I1 flowing and it is in same direction, so it is plus. Plus voltage across inductor, L di by dt. So value for L is 0.2. This will be I2 upon dt equal to, your current enters into negative, so it will be positive. So that's your equation number B. So if you observe from equation number 2, you will get a straight away hint that you will be getting I2 of t, and that's what we wanted, because we wanted V2 of t. For getting V2 of t, we need I2 of t. So let's go for it. Arrange I2 of t equation. So if you simplify second equation, you get 0.2 upon dt plus 30 I1 0 plus 30 I2 0 plus equal to 10. But if I need to find I2 of t, I don't need I1 term. The term should be in terms of I2 itself. So for this, I need to use equation number 1. The equation number 1 which we got is 40 I1 0 plus 30 I2 0 plus equal to 10. So from this equation, I need to find I1 value. So here I1 0 plus will be equal to 10 minus 30 I2 0 plus whole upon it will be 40. So put this I1 value in this equation. So you'll get the whole equation in terms of I2. So it will be 0.2 di2 0 plus upon dt plus 30. Your I1 will be 30 minus 10 I2 0 plus upon 40 plus 30 I2 0 plus equal to 10. So simplify the above equation, my dear friends. So you'll get 0.2 di2 0 plus upon dt plus, so divide 30 by 40. The value which you get after dividing 30 by 40 is nothing but 0.75. So multiply 0.75 into 10. So if you multiply 0.75 into 10, you get 7.5 minus, then you multiply 0.75 into 30. The value which you get is 22.5 I2 of 0 plus 30 I2 0 plus equal to 10. Simplify the term. The number should be shifted to RHS. The only term should be there is differential part and I2 term. Simplify the equation. So the equation which you get is 0.2 di2 0 plus upon dt plus, so it will be, simplify the term, it will be minus 22.5 plus 30, the value which you get is 7.47 I2 0 plus equal to 10 minus 7.5, the value which you get is 2.5. Compare the above equation with di2 upon dt plus pi2 equal to q. The value of p is nothing but equal to, and q we need to find. For finding this value, the coefficient of di2 upon dt has to be equal to 1. So I need to divide throughout by 0.2. So the equation which I get after dividing throughout by 0.2 is 7.47 divided by 0.2. The value which I get is 37.35 I2 0 plus, and next value which I get 2.5 divided by 0.2 is 12.5. So if I compare the above equation, I get the value for P is nothing but 37.35, and the value for Q which I get is 12.25. Now I can find the value of I2, that is nothing but e raised to minus pt integration q e raised to pt into dt plus k e raised to minus pt. Now put the value of p and q in this equation so that I can get the value of I2. So let's do it. If I put the value of p and q in the above equation, the equation which I get is I2 of t is equal to, my dear friends, e raised to minus 37.35 into t into q value is 12.5 into e raised to p value is 37.35t into dt plus into k into e raised to minus is 37.35 into t. So simplify this term, it is constant, so you take it outside. So I2 of t is equal to e raised to minus 37.35 into t is 12.5. If you integrate this, you will be getting 37.35 into t upon 37 plus 35 plus k into e raised to minus 37.35 into t. So the base is same and the power is different, exactly opposite. If you add them, you will get 0. So anything raised to 0, you get 1. So if you simplify, your I2 of t is equal to 12.5 divided by 37.35. 12.5 divided by 37.35 you get as 0.33 plus k into e raised to minus 37.35 into t. Now I need to find the value for k. For finding the value of k, I need to put t is equal to 0. So the equation will be I2 of 0 plus equal to 0.33 plus k. Anything raised to 0 is 1. So I've already found out the value for I2. The value for I2 which we have found out in the earlier case which we got is nothing but equal to 0. So your value for k will be minus 0.33. So substitute the value of k in the above equation. So you get I2 of t is equal to 0.33 minus 0.33 e raised to minus 337.35 into t. So your I2 of t can be written as 0.33 bracket 1 minus e raised to minus 37.35 into t. This which you got was the value for I2 of t. So after finding I2 of t, my dear friends, I need to find V2. So for finding V2, my dear friends, we have an inductor. The basic formula for inductor is nothing but V is equal to L di upon dt. Let's apply this formula. So V2 of t will be the value of inductor in the previous case, sum, which is given to us in the question, is 0.2 Henry. So is equal to 0.2 d by dt, and the current which we got is I2 of t. So put the value of I2 of t over here. So the V2 of t equation which we get is V2 of t is equal to 0.2 d by dt. Value of I2 of t is 0.3 bracket 1 minus e raised to minus 37.35 into t. So this is constant, take it outside. So V2 of t is equal to, just multiply 0.2 into 0.3. The value which you get is 0.06. So d by dt bracket 1 minus e raised to minus 37.35 into t. So differentiate. So V2 of t is equal to, my dear friends, 0.06. If I differentiate one respect to t, so that is constant, so derivative will be 0 minus exponential. Exponential derivative is as it is. Since you are differentiating respect to t, so t coefficient is nothing but minus 37.35. So minus minus will be plus. So V2 of t will be equal to 0.06 into 37.35. So value which I get is 2.24 into e raised to minus 37.35 into t. That's the value for V2. So that was expected from this sum. I hope you got this sum. Keep on practicing, guys. Thank you so much. Signing off.